So, concave down would imply that the second derivative was negative, just as the first derivative is the slope of f. The second derivative is the slope of the graph of f prime. So, when I ask you to think about the slope of this curve and whether it's positive or negative, I'm really asking you to think about the second derivative. So the slope of the curve right here is positive, so the second derivative is negative. The second derivative is getting smaller, and now it's 0. And now the second derivative is negative, 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 because we're thinking of the slope of the tangent line in all these places. Once we get down to here, now the slope is 0 again, and now the slope is positive. And again, we're taking the slope of the first derivative. So we're talking about the second derivative, and we saw that it's negative only when the x values are between 8 and 16 and smaller than negative 8. These are all the places where the slope of the graph of the derivative is negative. These are all the places where the second derivative is negative. These are the places where f is concave down, not on 0, 16. Okay, what about part B? F is increasing on the interval from negative 8 to 8. Well, the graph of f prime tells us the slope. And the slope at negative 8 is a negative. If the slope of f is negative here, then it's actually decreasing. It's decreasing pretty fast, but now it's decreasing a little more slowly until the slope is 0. It's not changing at all. And now the slope is positive, but small. So now it's increasing. And it's increasing more quickly now. And it's increasing really quickly. Anyway, is f increasing on the entire interval? No, because when the derivative is negative, it's decreasing. So it's only increasing from 0 to 8, and actually from 0 and above. But definitely not from negative 8 to 0, and therefore we can rule out B. C, f has a local minimum at negative 8. Oh my god, no. No, because when a function has a local minimum or maximum, that is, when a function has a local extremum, then f prime will be 0. And this is the graph of f prime, and it sure isn't 0 right there. The graph of f prime has a local minimum, but the graph of f, no, 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 no. Which, by the process of elimination, brings us to D. I guess D must be true. Let's go ahead and think it through, though, and flesh it out. F has a point of inflection when x is 16. All right, for this graph on top, I'm going to graph what a possible f might look like given the slope graph below it. So we don't really know where 0 is, but we know where the 8 and the 16 on the x-axis are. So the slope begins at 0, and then it's positive but small, and the slope gets bigger and bigger and bigger until 8, it reaches its maximum slope. You can see that right at this point, the slope is 0, like it says in the graph, and then it's a positive slope right here, but a really small positive slope, and then the slope gets bigger, and it's getting bigger until 8, it reaches the highest point. This is the highest slope, so in the graph of f, it's actually not its highest point, but it's where it's going to be the steepest. So now we have to become less steep. It's still going to be positive, but it'll be less steep, less steep, less steep, less steep, until we get to 16 when it's 0 again. So less steep, but still positive, less steep, but still positive, until the slope here is 0, just like it says at 16. And then as we move to the right of 16, the slope becomes positive again, but very little positive. But then it gets positive, more positive, more positive. So the slope becomes positive again and starts to get steeper. So the question is there a point of inflection at x equals 16? And the answer is yes, because there's concave down before it and concave up after it. Last thing to note is that an inflection point happens when the graph's function has a slope that's getting bigger and then suddenly starts getting smaller. So if this is the graph, notice that the slope is getting smaller, 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 and then it starts to get bigger, 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 bigger. So when the slope's rate of change changes directions, you have an inflection point. And you can see that here that the slope is getting smaller and then it starts to get bigger. So there will be an inflection point here. There would also be an inflection point here because the slope is growing and suddenly it's getting smaller. You can see that happening in the graph of f, this potential graph of f. The slope is the steepness of the tangent line. It's getting bigger, and then suddenly it starts changing directions and now it's getting smaller, smaller. Well, I hope this helped. Joyce D.